How would the mass and weight of an object on the moon compare to the mass and weight of the same object on Earth? So if we have an object on the moon, its mass would be exactly the same as that on Earth because the inertia does not change depending on location. On the moon, however, the force of gravity down is less because the strength of the gravitational field is less. So mass would be the same, but weight would be less on the moon. A 40 kilogram child exerts a 100 Newton force on a 50 kilogram object. The magnitude of the force the object exerts on the child, for every force there's an equal and opposite force, that's Newton's third law, would be 100 newtons. A student stands in an elevator that travels from the first floor to the 10th floor of a building. The student exerts the greatest force on the floor when the elevator is. So if we have the person on the elevator, in the elevator, and the elevator starts to accelerate upwards, the only way that can happen is if the floor starts to push up with a greater force than the weight of the student down. So the force normal is larger, so the equal and opposite force is the student pushing on the ground. So the answer is accelerating upward as it leaves the floor. A 5 kilogram box is sliding across a level floor. The box is acted upon by a force of 27 newtons to the east and a frictional force of 17 newtons to the west. What is the magnitude of the acceleration of the box? So let's do an F-net equation. F-net equals ma equals, we'll call to the right positive, so that's plus 27 newtons minus 17 newtons. So that's going to give us, if we have a mass of 5 kilograms times a, 27 minus 17 is 10, and the acceleration is going to be 2 meters per second squared. That's going to be to the east, but they only asked for the magnitude. A 12 kilogram cart is moving at a speed of 0.25 meters per second. After the speed is tripled, what happens to the inertia? Remember, mass or inertia does not change depending on speed, so therefore the answer is unchanged. An object weighs 2 newtons is pushed across a horizontal frictionless surface by a horizontal force of 4 newtons. The magnitude of the net force acting on the object is going to be that force that's pushing on it. So the only force, remember 2 newtons is the weight, so we have a 2 newton force of the force normal and a 2 newton force of the force of gravity. Those cancel out. The net force is going to be that force of push, and that force of push is 4 newtons. Equilibrium is defined as when the net force is 0. So when is the net force 0? The magnitude of the block's acceleration would be 0. No net force means no acceleration. A rubber block weighing 60 newtons is at rest on a horizontal surface of dry asphalt. What is the magnitude of the minimum force needed to start the rubber block moving? So to get it moving, we need to apply a force that is large enough so that it overcomes the maximum frictional force. Now, it's at rest, so we have to overcome this static friction. So that's going to be FF(S) equals mu S Fn. So what is that? Well, we're going to need our reference table. So it's rubber on dry asphalt. So rubber on dry asphalt for static is 0.85. So we're going to put in 0.85. And for the block, because it's on a horizontal surface, the force normal will be equal to the weight. And we know the formula for weight is Fugger-Mugger, mg. So we can just put in for Fn, mg. So what's that? Mass times gravity? Well, we don't have to multiply it because they gave us the actual full weight in newtons. So that's just going to be 60 newtons. 60 times 0.85, that frictional force that we have to overcome is 51 newtons. The data table below lists the mass and speed of 4 different objects. Which object has the greatest inertia? Inertia is just mass. So which one has the greatest mass? 8 kilograms. So the answer is D. Okay. A constant eastward horizontal force of 70 newtons is applied to a 20 kilogram crate. So we have a 20 kilogram crate and we have a force of 70 newtons to the east. And it's moving towards the east on a level floor, so its velocity is this direction. If the frictional force on the crate has a magnitude of 10 newtons, so there's our frictional force, what is the magnitude of the crate's acceleration? So that's going to be F net equals ma equals, now we sum the forces. We'll call to the right positive, so that's going to be 70 newtons. To the left is negative, minus 10 newtons. The mass of the block is 20 kilograms, so that's going to be 20 kilograms times A. 70 minus 10 is 60, and 60 divided by 20 is 3 meters per second squared.